Hello everyone to this webinar for DataBri-X. So today we will dive into the tools, session 1, and explore essential tools for acquisition. So my name is Robert David from Semantic Web Company, and so I'm happy to give an introduction today before we look at the tools. And yeah, so to provide a basis to start with, we are looking at the DataBri-X toolbox architecture. So the toolbox is basically governed by a process called GenPlane, so GenPlane data governance, which lets us define processes using tools and policies as criteria for these processes. For example, we can optimize regarding the power consumption to minimize it. So GenPlane allows us to pick specific tools to create workflows. And then as the next step, deploy these tools into operation and execute them with monitoring, orchestration, and also access to data spaces. So the tools are basically the DataBri-X toolbox consists of many tools for different purposes from all the partners, 22 tools in total, which can be used by GenPlane to plan these workflows. And every tool is provided in a Dockerized form as using Docker container, and exposes its functionality via a web API using OpenAPI for integration. So if we look at the GenPlane data governance process, we can see here that we have different phases for the data lifecycle, or stages for the data lifecycle. Plan, acquire, assure, describe, preserve, discover, integrate, and analyze. And for today's webinar, we will focus on tools in the acquire phase, so tools that can be used for data acquisition. So for today's tools, we have 3 partners presenting with 5 tools in total. We start off with Athena Research. Harry will present Twit Hoard, a tool that can be used to gather and summarize tweets, perform sentiment analysis, and visualize them. Then followed by Guardtime, Tamo will present the real-world data engine, which provides auditable, privacy-preserving computation using secure and traceable processing for data sharing with respect to legal frameworks. And then the 3 remaining tools will be presented by LSTech, by Pelayo, where we have the Data Anonymizer, which lets you configure your specific anonymization for data. We have NetNous, which characterizes time series evolution against the baseline, offers insights into trends, and provides a comprehensive understanding of data dynamics. And CostNous, which gathers different data types from file systems, facilitates aggregation, and supports time series forecasting for data exploration. So these are the 5 tools we will look at today. And with this, I would like to hand over to Harry from Athena Research to present Twit Hoard.
Hello, Robert. Thank you for the introduction. Just a minute to prepare the slideshow. So, I'm Harry Nakos from Athena Research Centre, and I will be presenting Twit Hoard, which is a tool, a web application used for collecting tweets using the Twitter API and performing analysis of collected tweets on the background and shown on the web application. Twit Hoard has been developed in the Information Management Systems Institute in the Athena Research Centre in Athens, Greece. So, what does Twit Hoard provide? Twit Hoard provides the ability to collect tweets based on specified criteria by the user. It offers the ability to explore collected tweets and elements of the collected tweets. Twit Hoard is able to summarize tweets and also provide the graphical exploration of tweet terms and users. It also has the ability to rank users from that posted the tweets in the collection and present the influential users among the users participating in the collection. It also has the ability to perform sentiment analysis of collected tweets. So the first step in order to begin a campaign is to specify the criteria of the campaign. The user can specify the tweet terms to track, terms that appear in tweet texts. The user can also specify Twitter users that the user needs to have tracked regarding their posts. Also, the text language can be specified, the tweet location, and an interesting ability is the ability to adapt tweet terms to extend the specified terms by terms that are deemed relevant by the engine, relevant to the terms already specified. So these are automatic terms that are added and removed as the campaign progresses. The user can specify when the collection procedure starts and how long it lasts. And since the collection can go to the past up to a specific, up to a limited time that Twitter provides, the user can specify whether only new tweets or old and new tweets need to be collected. And the priority, whether new tweets are first are collected first, then and then the old ones, or the priority goes to the old ones. This is the overview page of a campaign, where the user can see how many. The user can see the load of the requests, how many requests happen, regarding both the standard search and the adaptive search, if the adaptive search is activated. A campaign is divided into runs, where the criteria may be different, and the tweets that are collected in each run are also presented to the user. Also, an event log of interesting events that happen throughout the campaign is presented to the user. For example, if a term has been added to the campaign by the adaptive procedure, or a term is removed. The campaign data view presents the elements of the collection that is the elements that are together make up the collection. These elements are the tweets themselves, the terms, the broken down terms that appear in the tweet text, the users that appear in the collection, and the web content, that is the web pages that tweets that tweet text links to. Also, the Twit Hoard user has the ability to apply filtering on the collection throughout all these elements. That is, select specific terms that wants to appear in the tweets. And this way, the tweets are filtered. Tweets that only have these terms are presented to the user. Tweet summarization is another ability that the Twit Hoard user has, where summarization here is defined by the process to have a subset of collected tweets that is considered representative of the collection set. This is up to the Twit Hoard user to define how many numbers the summary has to have, whether the tweets in the summary need to be to the similar side, closer to the similar side, or towards the diverse side, and the method which takes into account the terms appearing in the tweet texts. The methods can be term frequency or term frequency inverse document frequency. The ability to explore the dataset is also made available to the user. Users and terms that constitute the dataset are presented in a graphical way, and terms and users can be added and removed from the graph interactively. The edges denote links between users and terms. The thicker an edge is, the more times the user has mentioned a term in their tweets. Another interesting capability of Twit Hoard is the ability to calculate and explore influential users in the tweet collection. 4 ranking methods are available. Twitter rank is an interesting network-based method that is similar to PageRank, where an influence is considered to be proportionate to the influence of the followers of a user. More simpler approaches are the followers as a metric for signifying influence, the number of followers, which is the audience size, the number of retweets, which signifies the ability to pass tweets. The higher the number of retweets, the higher the propagation of a specific tweet in the network of a user, and the mentions, which is an indication of the user's ability to interact with the audience, or maybe the other way around, the audience, the extent to which the audience wants to interact with the user. And the last capability of Twit Hoard is sentiment analysis on tweet text, where tweet text is given a score from the most negative to the most positive. The distribution of the sentiment score is presented in the chart, and also the ability to range the tweet text in the collection is given to the user. The ability to filter the tweets and present only the tweets that fall within a specific sentiment score range. This is available for English tweets only. So that's all from me. Any questions can be directed to me after the end of all the presentations. And thank you on my side. Up next is Tarmo Luman from Guardtime to present Guardtime tools. Thank you.
Hello, I am Tarmo from Guardtime, and today I will be presenting a solution called Real-World Data Engine. So basically, Real-World Data Engine is a tool that provides auditable, privacy-preserving, multi-party computation. And now we can go into the details about what this exactly means. Basically, we can use this tool if there is data about the same subjects, but it is kept in separate data locations while using the same identifiers, like personal ID codes or similar. And there are plenty of use cases where data cannot be linked for legal reasons, etc. Real-World Data Engine provides secure, traceable data access and sharing, and thus enables data reusability. We have paid close attention to all the legal frameworks and regulations so that sensitive data could be accessed in a trusted way using this tool. But in general, the purpose of a Real-World Data Engine is to get trusted aggregated data about data subjects while respecting data privacy. So the result is always just a number, basically a number of data subjects that meet certain criteria. And information about those criteria being met or not can be then obtained from a number of data sources. And now let's turn to auditable part. Because originally this tool was developed to make agreements possible which are based on sensitive data, and the task was basically to get a tool that provides trusted outputs while not exposing sensitive data. So we built in this bulletin board solution there. So every step that is being taken in this system with the data gets stamped and blockchain stored in blockchain, not the data, but the event happening. And so this tool can ensure that all the steps that were agreed that would be performed with the data will be performed exactly as was agreed. So what would be the use cases for such a system then? We started in medical research subjects, but generally there is no limit, as this tool as an output only provides aggregate numbers. Then it's most suitable for all kinds of statistics in any field that uses sensitive data. But also, as the main effort when using this system is about setting it up and connecting the databases, while later all the processing happens automatically, then it's also a great fit for any decision support system that requires fresh sensitive data. So it can be set up to update the result with needed regularity. It can run without costing precious human working hours. And that is basically it. I can be contacted on this email and I will be happy to answer any questions after the presentations. And now I will be handing over to Pelayo from LSTech. Thank you.
Hello, everyone. Thank you for the introduction and for the previous presentations. My name is Evangelos Kotsifakos. I am presenting LSTech, which is an SME that specializes in big data analytics mainly. We also build our own algorithms for forecasting, optimization, cost attribution, and network analysis and anomaly detection, some of them, with main customers in telco and fintech. We participate in this project with 3 of our main tools that will be presented right away. As a short introduction, I would like to say that these tools can be used in a large variety of applications. And in this toolbox, they can be associated and linked to other tools so that they can help in having a pipeline to support a data management project. So these tools can be used as standalone tools through APIs, but also can be part of a larger pipeline. And this goes for all the tools in DataBri-X methodology. And this is the whole scope of the project and the toolbox. And furthermore, I would like to make a clarification about the acquisition process of the data that this session is about. We may say the word acquire and acquisition, but in these specific tools, we don't mean that we try to find the initial data, the raw data, but rather than exploiting the raw data, the raw input to acquire some more, let's say, intuitive data that can be helpful to the use cases. So we will present 3 tools. Pelayo, my colleague, will do the presentation, and we will focus on the tool that will be used in the use case of the DataBri-X project. Thank you from my side. Pelayo, the floor is yours. Thank you.
Thank you, Evangelos. So in terms of the first tool, we have provided the Data Anonymizer tool, which is designed to mask critical information for any kind of ordered data, thus ensuring compliance and security. Of course, the level of masking can be tuned according to the user needs, laws, internal politics, or any other preference, allowing an extra layer of personalization depending on each use case. This tool is part of the toolbox, but it's not present in any concrete use case, but it can ensure compliance and security in every dataset containing critical information inside any DataBri-X workflow or any other thing. As for the algorithm, the anonymization tool is capable of parsing the dataset and mask the last characters of the critical columns. It uses a Python and Postgres database backend, which is easily scalable and efficient for large datasets, providing service for almost any dataset present in a DataBri-X workflow. Also, it has a layer of personalization, allowing users to select their sensitive data and masking level. We'll see now how it works, the input and output of the tool, where the input of the tool will consist of these 2 parameters, which are the data and the metadata, where the metadata will be handling all information about the dataset, as you can see in the image in the left. Also, it will include the sensitive columns list, which will list every sensitive column in the dataset, which is very useful for very large dataset with lots of columns. And the data itself can be any type of data in any order, but in a column-like structure, as you see in the image. This data will be stored and anonymized, as we can see here, outputting a response, and the dataset with the dataset already masked. Of course, this is a simple example, but its main purpose is in masking IPs or MAC directions in IoT or traffic datasets, which are more sensible to this type of masking. This leads us to the next tool, which is NetNous, which is a tool capable of performing anomaly detection on big datasets, allowing for rapid detection and response on flow tracing tool malfunctions, careless clients, poorly built applications, or malevolent attacks. It's part of the toolbox and can detect anomalies in different datasets regarding service failures or attacks. This tool works well also in masked data, as in IoT datasets with addresses that were masked by the anonymization tool, so it can work perfectly with the previous tool. And its algorithm was specially designed for anomaly detection in big telco datasets, allowing for a rapid intervention on compromised systems. This is done thanks to an advanced unsupervised machine learning algorithm, which intelligently identify irregularities, learning about the consistency and baseline of the specific dataset, outlining potential threats within vast data. The algorithm learns from the dataset itself, independently of the type of data, as it has not been trained into a specific type or biased data. This type of algorithm is done to be precise, but not biased into any type of location, time of the day, or any other external factors, ensuring correct anomaly detection in big data. This proactive approach is also essential for maintaining data integrity and compliance, ensuring the safety of the datasets, but also providing insights about when and how the anomalies occur, leading to possible actions against them and further analysis on the new data acquired. In terms of input-output, we have here this simple API approach, where you send some kind of ordered data, like in the tool before, usually a time order one with a timestamp and some values, as you can see. And you receive as a response the same data, but this time labeled as anomaly or regular data. So we do this acquire phase of the data, acquiring more data over the same data that's already acquired. Once again, this is a simple and visual example. So usually the label will not be potential anomaly or text itself. It's usually 1 or 0, or in other terms, a binary output. But and for simplicity in the parsing and of the output file. Also, the output format might change, but this is the idea behind it. However, the idea behind our last tool, CostNous, is a little bit different, as it is a tool designed to perform service usage forecasting, providing valuable insights for strategic decision-making in service provision or traffic management in telecommunications. This exact functionality will be used in use case 1 with our partner Nova in order to forecast network resource usage and provide insights about future usage to the company, so they can predict malfunctions, plan maintenance and upgrades of the infrastructure or any other action. We are currently connecting with Nova, gathering insights from different datasets and adapting the workflow and algorithm to the main use in the use case. We've done a couple of iterations with some interesting results, which I will show later on. And currently we're improving over more data and different types of aggregations, as I will explain later. This is possible thanks to an unsupervised learning algorithm, specifically designed for telecommunication data analysis. This one operates without the need for predefined labels or classifications, enabling to uncover hidden patterns and relationships within the data autonomously. The algorithm is specifically effective understanding seasonality, that is the fact of the data being periodic of some kind, which is a critical factor in this kind of datasets. These datasets have a significant influence over service searches and this kind of seasonality also. And the algorithm can also analyze historical data, adapting to the inherent fluctuation and periodicity of any organic data. In terms of the use case, the practical application of this algorithm are many, from optimizing network capacity to better managing resources during peak periods or taking any other action. Also, this level of predictive accuracy empowers telecom companies to enhance the customer satisfaction by proactively addressing service needs and expectations even before they occur or even before the demands occur. Okay, this is the theory, but this is how it works. In simple terms, we have some kind of telco data that usually has this kind of very typical columns, that is a user identification or a label for a specific user, a timestamp or a time window where the event occurred, and the traffic can be kilobytes or megabytes that is occurring in this time window. So the first step will be aggregate this data in order to take some insights. And in this example, we are aggregating in time windows, different time windows, and calculating the total amount of traffic in a specific amount of time. With this aggregated data, we can do a prediction over time. The prediction usually have two components in this tool. The green one, which represents this seasonality or periodicity in the datasets, and the yellow one, which is the total prediction, by adding to the mix the volume prediction, or in other words, the amplitude of this seasonality. So with this flow, we were able to estimate here some traffic prediction for a specific time of the day, as you can see in the total orange curve that is predicting the next time or the next traffic from the blue curve. But this is not all, and we can start playing around with different types of aggregations or grouping, such as time frame, technology, spatial frame or location, network capacity, seasonality, or any other external factors. With this kind of different aggregations, we can gather different kind of predictions, like what will be the load of traffic of this area in maybe 2 weeks if you are using location and a higher time frame, or what will be the peak traffic tomorrow in a different time frame. Or we can take into account the network capacity and ask what is the likelihood of a network overload in this location over the weekend. Or we use historical data, location, maybe some external factors like holiday days, and we can discover what are the seasonal trends in data usage in any region. As you see, the possibilities are almost endless, but as I already finished, I let you thinking about it. Thank you.
Thank you, Pelayo. Yeah, thank you. Thanks to all the presenters for the great presentations. I think this was really interesting. So we are at the end of the tool presentations now, and yeah, thanks to the audience for the attention. And so I'm asking now if there are any questions about the tools that you might have. Okay, I have a question I would like to ask Harry about Twit Hoard. So could you tell me, so Twit Hoard can adapt its search by extending with specified search terms with relevant terms. So how are these relevant terms determined?
Okay. The collection is divided in specific windows, time windows, and the terms that appear, the collection progresses with a specific search set in general. So the tweets collected in specific time windows are analyzed regarding the terms they contain, terms beyond the collected, the terms in the search criteria. So terms that appear frequently in consecutive time windows that are not in the original search criteria are investigated on their own to see what kind of results they bring in before they are added to the criteria as a part of the adaptive search. And if they have an overlap, a significant overlap, but they are not too general, I mean, a term could very well be really general and could bring in everything. In that case, this would not be added in the adaptive search front. But if the results seem to augment the dataset a bit, then this and there is an overlap on the tweets that they bring, that the original search brings and this candidate search brings, then this is added at the criteria for this adaptive search. So to conclude, there needs to be an overlap that seems significant to extend the search. Okay.
Okay, thank you. So you basically determine the significant ones that stand out to just general ones, and that have a strong relation to the specified search terms, right?
Yes, relation regarding their co-appearance.
Mm-hmm.
At first, the co-appearance is what makes it a candidate to investigate. Then this candidate is investigated on their own to see what kind of tweets it brings on their own. Mm-hmm. And if there is this overlap, good overlap, not something very general that brings in much more and irrelevant tweets, then this is added as the adaptive search part of the campaign.
Okay, thank you.
Thank you.
So the next question we have is a question to Tamo about the real-world data engine. At what point is the data decrypted for the final presentation?
That's a very good question. Basically, in order to get the result, there is no need to decrypt the data at any point. The possibility to decrypt the data is only kept at the data source, and the reason for that is auditability. So there can be independent audit in case there is doubt about the information used or entered. So this is strictly for auditability use, and there is no need to decrypt at any point to get the result.
Okay, thank you. Okay, and then yeah, I would like to ask a final question to Pelayo about the tools. How do you deal with real-time data? So these tools working on this time series, of course, it's interesting to run that in real time. And you also mentioned big data. So how do you deal with that in practice?
Yeah, specifically in the use case, we are not dealing with real data applications, but we have done some things with that. And in the two tools, NetNous and CostNous, they can deal with real data with an implementation in the cloud, and it will depend a little bit of course, in the client and how they store the data, but they have some applications in real data like NetNous for anomaly detection. It can handle real data and and get some alarms if they detect these anomalies. But of course, the implementation will depend of the final client a lot.
Okay, thank you. So, are there any more questions? Doesn't seem to be the case. Okay, then thanks again to all the presenters. Really great presentations. It was very interesting. And yeah, so I would like to point out here at the end of our session today, I would like to point out the next session that we will have, where we'll look then into the next phase of the data life cycle, the assurance. So we will look into shaping the data assurance landscape with new tool presentations, and this will take place on the 19th of March at 2 p.m. Central European Time. So thank you all for joining, and see you next time.